Okay, in this video, I'm going to talk about subbasis for a topology. Now, let's define what is a subbasis for a topology on the given set. So here is the formal definition of a subbasis for a topology on X. Let's say X is a set. Let's X is a given set. Then a subbasis script S for a topology on the set X is a collection of subsets of X whose union equals the set X itself. So basically, X is a given. If X is a given set, then a subbasis for a topology on X is the collection of the subset of X. When you take the union of those subset, the union is the set X itself. Then that collection is called a subbasis for a topology on the given set X. For example, let's say X is a set whose elements are A, B, C, and D, and let's take this collection of the subset of X. In our collection, the subset of X are A, B, and C, and B, C, D. Now, in our collection of the subset of X, we have those two subsets, this one and that one. And when you take the union of these two subsets, that's gonna be the set X itself. So this collection is a basis. Is a base. Sorry, not is a basis. Is a subbasis for a topology. On X. Okay, so basically subbasis for a topology on the given set is nothing. It's just the collection of the subset of the X. When you take the union of those subset, the union must be set X itself. Okay, so in our previous video, we talk about basis for a topology, and then also we learn how to generate the topology using the basis. And also you can, if you have a subbasis for a topology on the given set, you can use that subbasis to generate the topology. Now next we're going to talk how to generate the topology using a subbasis. Okay, so this is our first definition. This is the definition per subbasis, and now here is the one more definition. So here I'm gonna talk how to generate the topology using a subbasis. The topology, again X is a set. The topology generated by subbasis. The topology generated by a subbasis script S is defined to be the collection tau of all unions of union of finite intersection finite intersections of elements of S of this subbasis. So basically the topology generated by a subbasis S is defined to be the collection tau of all the unions of finite intersection of the element of the subbasis. So to to compute the topology generated by a subbasis, we need two operations. The first one, it says finite intersection of the element of S. So you just take the finite intersection of the element of the subbasis, and then you take the union of those intersection. Once take the all possible union of those intersection, then that collection is the topology generated by a subbasis. I'll give you example, then it's gonna be clear. But before I give you example, so let me just write down as a note. So as I said before, to compute the topology generated by a subbasis, we need to use two operations. One of them is you take all the finite intersection of the element of subbasis, and after that you take all the possible unions of those finite intersections. So let me just write down as a note the element elements of tau, where tau is the topology generated by subbasis script as elements of tau can be obtained using the following two operation. Okay, following two operation. For the first one is taking intersection of sets in S. So basically those operations, they come from the definition of the topology generated by the subbasis, which we defined a few minutes ago. So to get to compute the topology generated by the subbasis, we need the following two operations, and one of them is you just take the intersection of the sets in S. When you take the intersection of the sets in subbasis, then that collection is gonna be basically basis for the topology. So you can find the basis, or you can generate the basis using the subbasis. To generate the basis, what you need to do, you take all possible finite intersection of the sets in subbasis. That's the first operation. So this operation, it generates a basis for a topology in the given set, and then you need to taking arbitrary unions of sets obtained in step 1. So basically we are taking all the possible union of basis element. Okay, so once we do those two operations, then we can compute the topology generated by a subbasis. Now let me give you example. Let's say my set is A, B, C, and D, and then this is a subbasis for our topology on this set X. B, C, and D is a subbasis. We have already checked this collection forms a subbasis for our topology in X, is a subbasis. Then to now to generate the to generate the basis for a topology on X using this subbasis, what you need to do, that's our first operation in this list. So you just take the intersection you you take the finite intersection of the elements in this subbasis. Now when you take the intersection of this set with itself, so you're gonna get the A, B, C, and then again you take the intersection of this set with itself, then that will give B, C, D. Now we take the intersection of these two, so that will give us B and C. So this is the basis. This one is the basis for the topology on X, and if you want, you can check whether this collection forms a basis for a topology in on X or not. Even if you check, then you can see that this collection forms a topology. Forms a basis for a topology on X. So we done with the first step. Here we want to generate the topology using the subbasis. So these are the two operations that we need to use. We just did the first, and then second one, what you do is it says taking the arbitrary union of the sets obtained in this step one. So after in step one we got this collection of the subset of X. Now we going to take all possible union of the elements of this set. So when you take the union of this the first one with itself, you're going to get A, B, C, and then you take the union of second one with itself, B, C, D. Take the union of third one with itself, B, C. Now take the union of first and second. If you take the union of first and second, it's gonna be A, B, C, D. That's gonna be our set X, the given set X. Then you take the union of first and last, that is A, B, C, which is already here. Then you take the union of B, C, this guy, second one, and then third one, which is B, C, D, is already here. Then you take the union of all these three, that's gonna be set X itself. And then you take the empty union. When you take the empty union, that's gonna be the empty set. So this one is a topology, generated by the subbasis. Topology generated by the subbasis this script S. So this is how you can compute the topology using the subbasis.